This lesson is on probability tree diagrams, and we'll be looking at drawing tree diagrams and then being able to use those tree diagrams to calculate probability, independent probability for those events. This slide also shows you your equipment list and some of the keywords that we'll be looking at, things like outcomes and independent. When we're looking at probability, things that are probability that is not dependent on what's happened in the past. Firstly, we need to look at constructing tree diagrams. So a typical part of a tree diagram will look like this, where we'll start off with your from the starting point, and you've got branches. So depending on how many outcomes there are, you'll have that many number of branches. So if you've got two options, for example here, heads and tails for flipping a coin, you'll have two branches, but sometimes you may even have three. For example, if you're taking different colored counters out of a bag and you've got three different colors, then you may even have three branches. And on each of the branches, you would then write the probability of each event or each outcome. So for example, the probability of getting ahead when you flip a coin is 0.5, and the probability can be written out as fractions, decimals. In this example, we've given some information about two people who sit their driving test, and we're giving the probabilities for the first, for Megan passing and then Rosie failing, and we asked to complete the tree diagram and then work out some of the probabilities. So in this first part, we're given the blank tree diagram already drawn out. So probability that Megan passes is 0.8. So I'm going to put that for Megan at 0.8 goes there, and because each part of the tree has to add up to 1, so therefore probability that she will fail will be 0.2. Both of them add up to 1. And then the probability that Rosie fails the test is 0.3. So here for Rosie failing is 0.3. So therefore it will be 0.7 for her to pass. And again, all I'm going to do is copy these two here. So 0.7 for passing and 0.3 for failing. And I'm also going to write out all the outcomes that, what would happen. So this could be Megan passing and Rosie passing. So that's a pass, 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 fail, Megan passing, but Rosie failing, and that's fail and pass. And then here we got both of them failing. Now, so we got the tree diagram, and that's the tree diagram complete. Find the probability that both of the women pass. So we're looking for now following just this path. So that's where both of them have passed. So that is 0.8. So pass, 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 and pass. So 0.8 times 0.7, which gives me 0.56. So for this, the probability for both of them passing will be 0.56. Next, find the probability that one of them fails. So that will be either one of them failing. So that will be either Megan passes and Rosie fails. So that's 0.8 times 0.3, which is equal to 0.24. And then or it'll be Megan failing and Rosie passing, so fail pass. So that'll be 0.2 times 0.7, which will give me 0.14. So we got pass and fail, or fail and pass. For the second part of the question, we need 0.24 plus 0.14, which gives me 0.38. And then again for the last part, find the probability at least one of them passing. So that will be at least, that means it could be pass fail or fail pass, or it could, but that also includes both of them passing. So it could be, so there's three options there. So it will be pass, 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 fail, or fail, pass. So so what we need to again do is add these three, 0.56 for the pass, pass, or pass, fail, 0.24, or fail, pass, 0.14, which gives me a total of 0.94. So what I would like you to do now is pause the video, try this question for yourself. Once you've completed the tree diagram and answer those questions, play the video and then I'll go through the answer. So for this question, the tree diagram looks like this: 0.6 for Matt scoring, and then 0.4 for not scoring, and then for Thomas 0.7 and 0.3 for missing, and the same for that half there. And listing out the outcomes: score, 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 miss, miss and score, and then miss, both Matt and Thomas missing their penalties. And again, I worked out the probabilities. So looking at the questions, find the probability that both of the boys missing. So that'll be this, follow this path here. So miss and miss. So that's 0.4 times 0.3 equals 0.12. Find the probability only one of the boys scoring. So that is either Matt scores and then Thomas misses, or Matt misses and Thomas scores. So that'll be looking at just these two paths. So score, miss, or miss and score. So these just those two, 0.18 and 0.28. Add those two numbers together, and the answer is 0.46. And finally, probability of at least one of the boys missing. Well, first part with the miss, that'll be either Matt scoring and Thomas missing, Matt missing his penalty and then Thomas scoring, but then that will also include both of them missing their penalties as well. So it says at least one of them, so that includes both of them missing. So then therefore that's these three probabilities. So to work out this answer, you just have to add the three probabilities and you end up with 0.58. In this example, we've got two sets of counters in two different bags. In bag A, 2 red and 5 blue counters. Bag B, there's 5 red and 7 blue counters. And the first part, we asked to draw the tree diagram. So here we've got two options for each bag. So if I start with bag A first, so bag A's got two options. Okay, and I'll label that as bag A, and there's either red or blue, and blue. And so for this, because there's 7 counters in total, 2 plus 5, so the fraction will be out of 7 for both parts. So there's 2 red, so that's 2 out of 7, and 5 out of 7 for the blue counters. And for the second bag, so bag B, we've got again 2 options for each one. So now we've got, so for bag B, again, there's red and blue. So that's red and blue, red and blue. And there's 5 red and 7 blue. So there's 12 counters in total. So, and there's 5 red and 7 out of 12 that are blue, and again 5 red, 5 out of 12, and 7 out of 12 that are blue. And again, I'm going to write down all the possible outcomes for my tree diagram. So I could have red from bag A and red from bag B. So that's red, 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 blue, blue, red, and blue, blue. Now, for the questions, it says write down the probability that both counters are red. So the both counters are red. I need to follow this path here. So it's red and red. So that's 2 over 7 times 5 over 12. So that will give me 10 divided by 7 times 12 is equal to 84. And that's my answer. Okay, so that's, I can leave that answer as 10 over 84, or I can simplify it as well, 5 over 42. For the second part, work out the probability that both counters are the same color. So that will give me either red, so we've got that already, which is 10 out of 84, and or it'll be blue. So the blue will give me 5 over 7 times 7 over 12. So 5 times 7 equals 35 divided by 84. So for this part, we've got red, which is 10 over 84, or blue, which is 35 over 84. So adding the fractions, that gives me 45 out of 84. So for the last part of this question, I can work out the probability that she chooses at least one blue counter. So at least one blue, so that could be having red on from the first bag and blue from the second bag, so red, blue, or blue and red, or that also includes having both of them blue as well. So we've already worked out the probability of both of them being blue. So for this first part, for it to be red and blue, so that's 2 over 7 times 7 over 12, and again 2 times 7 is 14 over 84, and for blue red it will be 5 over 7 times 5 over 12 is equal to 25 over 84. Now for the last part, okay, I just need to work out use the three probabilities, add them together. So that will be red, blue, which is 14 out of 84, or blue, red, which is 25 out of 84, plus or blue, which is 35 out of 84. That gives me 74. So that will be 74 out of 84 as the answer. So what I would like you to do now is pause the video, try this question, and once you've completed this question, play the video, and then I'll go through the answer. So for this question, what you should end up with is your tree diagram looks something like this, for him being late and not late, and with the probabilities on each of the branches. And look, I can work out each of the probabilities, so being late on Monday and late on Tuesday, late on Monday and not late on Tuesday, and so on. So I'll work out the 4 probabilities there. So the question says work out the probability that he is not late for both days. So he's not late on Monday and not late on Tuesday. So that will be this path here. So that gives us 3/4 times 7 over 9, 21 over 36. So for part C, we need to work out the probability that he's late at least on one day. So for this, we need to follow that he'll be late on Monday and late on Tuesday, or he'll be late on Monday but not late on Tuesday, and the last one will be he's not late on Monday but then he's also late on Tuesday. So you got 3 paths, 3 outcomes that we need to look at So there's these three fractions here, and then to get your answer, because we're going down the options, we're going to add those three fractions, and the final answer is 15/36. So for the main task of this lesson, I would like you to do one of the questions from the red, one of the questions from the amber, one of the questions from the green. So that's three questions in total. Once you've done your three questions, take a photo of your work, making sure you draw your trees and show all your working out, and upload an image of your work onto ClassCharts for you to have completed the work for this lesson.